First question, write 37,500 in scientific notation. 37,500. When writing a number in scientific notation, we have to write it as a product of a number between 1 and 10 and with a power of 10. So this can be written as 3.75 multiplied by 10 to the power 4. Then second question, we are given to simplify this. 3 over 8 minus 2 over 5 of 1 over 4. Here first we have to perform this operation of. It can be converted to a multiplication. So we have to write 3 over 8 minus 2 over 5 multiplied by 1 over 4. Now we can remove the common factors. 2 times 1, 2 times 2. Then 3 over 8 minus 1 over 5 times 2 is 10. Now we can take the common denominator. What is the common denominator here? 8 and 10, the common denominator is 40. 40 is the common denominator. The first fraction should be multiplied by 5. 5 times 8, 40. 5 times 3, 15. Then the second one by 4. 4 times 1 is 4. The answer is 11 over 40. Third question, find y. In this triangle, all the interior angles are given as 2y, 3y and 4y. We know that the sum of the three interior angles of a triangle is 180. So we can write the equation 4y plus 2y, 6y, 6y plus 3y, 9y. 9y equal to 180. Y equal to 180 divided by 9. The value of y is 20 degree. Question number 4. Which term is 37? In the progression, whose general term is 3n plus 4? Let's take n term is 37. Then we can equal the general term 3n plus 4 to 37. Now we have to find the value for n here. First, this plus 4 can be removed. 4 is subtracted from both sides. Then 3n is remaining. Here this side 3n minus 4 equal to 33. 3n equal to 33. Now we can divide both sides by 3. Then n equals 11. So 11 term is 37. 11 term is 37. Then question number 5. Simplify. We are given this expression 3x squared to the power 2 into 2x squared. A power of a power. Power goes to both the terms. So 3 to the power 2 multiplied by x to the power 2 to the power 2. 2 into 2 is 4. So the power of x is 4 now. Into 2 multiplied by x to the power 2. 3 to the power 2. The answer is 9. 3 is multiplied twice. So 9 times 2 is 18. Then x, when multiplying powers with the same bases, the indices are added. 4 plus 2 is 6. The answer is 18x to the power 6. Then question number 6. We are given this to solve. X minus 1 divided by 2 equal to 8. First we can remove this division by 2. For that we can multiply both sides by 2. Then 2 and 2 can be removed. Then x minus 1 equal to 8 times 2 is 16. Now we can remove this minus 1. For that 1 is added to both sides. Then x is equal to 16 plus 1 equal to 17. That is the final answer. Question number 7. Make A the subject of the formula S equals ut plus half at squared. We have to make A the subject. First we will remove this ut, the product of ut. For that ut is subtracted from both sides. S minus ut equal to ut plus half at squared minus ut. Then plus ut and minus ut are cancelled. Then here I will take this term to this one and interchange the sides. Then half at squared is equal to s minus ut. Now we can remove this half. For that both sides are multiplied by 2. I will use a bracket here. Then 2 and 2 are removed. At squared equal to 2 times s minus ut. Now to remove this t squared, we can divide both sides by t squared. T squared, dividing both sides by t squared. T squared to t squared, we can remove that. A is remaining now. A equal to 2 times s minus ut over t squared. That is the answer. Then question number 8. We are given to simplify this. 3x over 5 plus 7x over 2. We can take a common denominator here. What is the common denominator of 5 and 2? 10. The LCM of 5 and 2 is 10. Then the first fraction is multiplied by 2. 2 times 5, 10. 2 times 3x is 6x. 6x plus then this fraction. So the second fraction is multiplied by 5. 5 times 2, 10. 5 times 7 is 35. 35x. Now the denominators are same, so numerators can be added. 35 plus 6 is 41. 41x over 10. That is the answer. Question number 9. Magnitude of an interior angle of a regular polygon is 150 degrees. First question. Find the number of sides it has. In a polygon we know that the sum, if I draw a polygon like this is not a polygon relevant to this question. We can take an exterior angle like this. So, as this is a straight line, the sum of an interior angle and an exterior angle equal to 180 degrees. So, here the interior angle, the value of the interior angle is given as 150. So, we can find the value of the exterior angle. Exterior angle, the value of the exterior angle is 180 minus 150. That is 30 degree. So we can find the number of sides in each regular polygon. The sum of the exterior angles equal to 360 degrees. So sum of the exterior angles is 360. The magnitude of one exterior angle is 30. Now we can find the number of sides here. Number of angles is equal to the number of sides. So 12. 12 sides are there. Then second part. What is the special name of this regular polygon? This has 12 sides. A regular polygon with 12 sides is the dodecagon. Then question number 10. Find the value of x. I will draw the diagram. This is the diagram given for us. These two lines are parallel. Then this is 80 degree. This one is 120. This is x. Now how to find the value of x? If I join these 2 points, we get a triangle here. Then here we can find the magnitude of this angle by subtracting 120 from 180. So this is 60 degree. This angle is 60 degree. Then how to find the magnitude of this one? As these two are alternate angles, this magnitude is 80. As the sum of these two angles are 180, this one is 100 degree. Now we can find the value of x by taking the interior angle sum of this formed triangle. We can write x plus 100 plus 60 is 160 equal to 180. Then x equals 180 minus 160. 20 degrees is the answer. Question number 11. Find size. That means the width of the class interval 15 to 21. In 15 to 21, let's count the data that number of data that we can include in this class interval. 15, 16, 17, 18, 19, 20, then 21. So 7 data can be included in it. So the class size, class width of this class interval is 7. Then question number 12. Factorize. First one, 2x squared minus 98. We can take 2 out here. 2 is a common factor. So x squared is remaining here. If you take 2 out, 49 is remaining here. Now we can write 49 as a square. 7 squared. Now difference of 2 squares. We can use that. 2 times x minus 1 times x plus 7. That means if you take the difference of 2 squares as a squared minus b squared, two factors are, one is a minus b, the other one is a plus b. Then second one, a quadratic expression, x squared minus x minus 12. As the coefficient in the square term is 1 here, we are taking only this common term. Here the third term, the value is minus 12. So we have to factorize this term to take the addition as minus 1 and then the multiple as minus 12. So what are the two factors? One can be minus 4, the other one is plus 3. If you take the addition, you get minus 1. The multiplication here is minus 12. So we can use these two terms instead of this middle term. X squared minus 4x plus 3x minus 12. By taking two terms, we can take common factors out. X can be taken out. Then x minus 4 comes inside the bracket. Then here, if you take these two terms, plus 3 can be taken out. Then x minus 4. So x minus 4 is common here. X minus 4 times, then x is here, it comes plus 3. So this is the final answer. Question number 13. Height of a cuboid shaped water vessel with a square base is 1 meter. The height is given as 1 meter. And the side length of the square base is 50 centimeters. Find the capacity of it in liters. We can find the volume of the vessel by multiplying length by breadth by height. Length can be taken as 50 centimeters. Then breadth is also 50 centimeters. Then the height is 1 meter. That means 100 centimeters. So the volume can be taken in cubic centimeters. What is the value here? 5 times 5 is 25. How many zeros? 1, 2, 3, 4. 25,000 cubic centimeters. This is equal to the same value in milliliters, as 1 cubic centimeter is equal to 1 milliliter. So this can be converted to liters by dividing by 1000. Here I have done a mistake here, 4 zeros. So another zero should be written here. Then the answer is 250 liters. This is the capacity of the tank in the vessel in liters. Question number 14. Solve the inequality and represent the set of integral solutions on a number line. The inequality is 2x plus 1 greater than 8. First, this plus 1 can be removed by subtracting 1 from both sides. Then 2x is remaining in this side, greater than 8 minus 1. 2x greater than 7. Now both sides should be divided by 2. Then x greater than 3 and half. Now we want the integral solutions, only the integral solutions. I'll draw a number line like this. 0, then 1, 2, here 0, 3, 4, 5, 6, 7. Then x is greater than 3 and half. 3 and half is here, in between 3 and 4. So the first integer including this inequality is plus 4. Then plus 5, plus 6, plus 7. In this way we can represent the solutions. All should be integers. Question number 15. Find the gradient of the given straight line. We know that in a straight line, gradient is equal to the ratio between the difference of y coordinate values and the difference of x coordinate values. So, gradient, we are expressing it as m equal to, I will take the x coordinate of the point 6, 7. Sorry, y coordinate 7. Then the y coordinate in the other point is 4. 7 minus 4, the difference of the y coordinates. Then earlier term, the x coordinate is 6. 6 minus, then the other point, x coordinate is 0. 7 minus 4 is 3. 6 minus 0 is 6. So the answer half. That is the value of the gradient. Then question number 16. Simplify and write the answer as a decimal number. 1100. This is a binary number. So the other one 11. This is also a binary number. A subtraction. To subtract 1, we have to take 1 from the other side. Then here the value is 0. Here also 0. So we have to take 1 from this one. Then If this one is taken to the other side, this becomes 2 here. Here now 0. Then if we take this one to this side, it is 2. Now it is 1. So we have to take 1 from the other side. It becomes 2. Then the remaining is 1 now. Now let's do the subtraction. 2 minus 1 is 1. Then 1 minus 1, 0. Then 1 minus 0 is 1. Then 0. Here 0. Here also 1 here. So this is the final answer. Then we are asking to write this number as a decimal number. For that, we have to take the decimal values relevant to each digit here. Here 2 to the power 0. 2 to the power 0, the value is 1. Then we are adding that. Then the next one 2 to the power 1, but here 0. Then 2 to the power 2, we are adding that 4. Then 2 to the power 3, as it is 0, we are not taking that. Then the last one 2 to the power 4. The value is 16. As it is 1, we are taking that. So the decimal number 16 plus 4 is 20. 20 plus 1 is 21. This is a decimal number. Question number 17. Find the bearing of A from B. This is the diagram given for us. Here A, then here B. Then this is the north direction. Then 65 is the angle, 65 degree. Now when finding the bearing of A from B, we have to represent this north direction here. Then we have to find this angle. How to find this one? As these two are parallel lines, say both are north direction, so they are parallel. These two are allied angles, so we can find the magnitude of this angle. How to find x? The sum of two allied angles is 180. So x equal to 180 minus 65. The magnitude is now 115. Here this one is 115. Now to find this angle, we have to subtract 115 degree from 360, as the sum of the angles around the point is 360. We can subtract 115 from this. 10 minus 5 is 5. Then here 5. 5 minus 1, 4. 3 minus 1 is 2. So the bearing can be written as 245 degree, as the bearing should be given with 3 digits. Then question number 18. Find the value of x. Here we can find the adjacent angle of 108. The supplementary adjacent angle of 108 by subtracting 108 from 180 degree. So the magnitude here is 72. Now the other two angles, 2x plus 7x is 9x. Then 9x plus 72 degrees equal to 180. The sum of the interior angles of a triangle. So how to find x now? 9x equal to 180 minus 72. That is 108 degree. Then x equal to 108 degree divided by 9. 9 times 1 is 9. For 18, 9 times 2. 12 degrees the answer for x. Question number 19. The length of a scale diagram of a study room drawn to the scale 1 to 200 is 5 centimeter. Find the actual length of it in meters. First, let's read the scale 1 to 200. That means 1 centimeter represents 200 centimeters. Let's now convert this value to meters. We know that 100 centimeters is equal to 1 meter. Then this is equal to 2 meters. So 1 centimeter represents 2 meters. Then we have to find the actual length represented by 5 centimeters. 2 multiplied by 5. Now this is in meters. 10 meters. Question number 20. By using your basic knowledge of loci, find the locus of a point equidistant from P and Q and 3 meters away from the point P. Draw the rough diagram including all the information. I'll draw the diagram first. P and Q are given like this. The length is 4 centimeters, 4 meters. Equidistant from P and Q. For that we have to take the perpendicular bisector of this straight line PQ. To take the perpendicular bisector, we have to place the point of the compass here and draw an arc in both directions. Then without changing that distance, again we have to keep the point of compass here and draw 2 arcs intersecting the first 2 arcs. Then we have to join this straight line. Now this is the perpendicular bisect of this straight line PQ. These 4 are right angles, then these 2 lengths are equal. If you take any point on this straight line, the distances to P and Q are same. Then the other one, 3 meters away from the point Q, P. For that, we have to draw a circle by taking P as the center and the radius as 3 meters. If this length is 2 meters, it goes into this one, this direction. So we can draw a circle like this. So we can now mark 2 points here. This one and the intersecting points of the 2 loci. And this one. These 2 are the locus we need for this question.